Okay, to begin our final segment here, we it says carbohydrates, which means we're starting biochemical compounds. And in this case, that means sugars. Okay? Excuse me. So what we want you to be able to do, this is where this information comes from. As long as we take this in a nice, slow progression, nothing that would lead me to believe that we can't handle this. And what this means is we take information from here and because it's when you draw, whether you want to call these stitches, we call these ball seams, railroad tracks. The actual name for this is a Fisher projection formula. But in this case, the reason that this is important, one, two, oops, I got one too many. Okay, and what happens is it's how these different types of atoms are arranged, because we know that this is probably the most common way to write the molecule for glucose or its formula, correct? Okay, so everywhere that there's a line here, there's a carbon atom. There. Now, you don't need to write those in. It's just understood that where there's an intersection, there's a carbon atom, just like this. If you're writing cyclohexane, it's just understood that everywhere there's a or N intersection, that there's carbon atoms located there as well. So what we do here is some of these have different orientations, like this. Okay. Okay, so now we can account for every one of these atoms that are in that formula. Because if we go vertically here, okay, how many carbons do you see? Okay, then let's go ahead and count our oxygens. Got 1, 2, 3, 4, 5, 6. There's our 6 oxygens. Then for hydrogens, we've got 3 down here. Okay, 4, 5, 6, 7, 8, 9, 10, 11. Oh no, are we one short? Where's the last one? Yeah, since there's nothing written here, it's just understood. There's our 12th one. Okay, and this is where we start to differentiate between these different types of compounds, because how we explain this at the senior level is once you have this formula wrote out, okay, we tip it on its side here, just like chopping down a tree, if you want to look at it that way. And yeah, there's a specific way that we want you to be able to draw these structures out. So once we do that, okay, number 1 is right here. So here's a carbon atom here. Okay. Then when OH molecules are on the right-hand side, that means they're pointed down in the 3-dimensional structure. Okay. So here's carbon 1. Okay. So since carbon number 2 has an OH on the right-hand side, that means it goes down. Okay? So then on carbon number 3, this one, since it's on the left-hand side, that means it will go up. Carbon number 4 is also down. Okay, and then for our 5th one is also pointed down. And then what do we have on our 6th carbon? What does it illustrate there? We just go right on down the line, like you said, CH2OH. Okay. Now we're going to close that structure. Okay. Is anybody confused with how we got from this to this? And maybe you don't know what to ask. Because, and we'll go through more examples. All right. Okay. So now in our next step, probably going to get really good at drawing 6-sided figures. Then by the time you're done drawing them really well, school year's over. Okay. A lot of this remains the same, okay? But what looks different between this, we call this step 1, this step 2, and then this is step 3. So what looks different from step 2 to step 3? It's closed for one, okay? And all you need to know, if in the senior level class, there's a way that we describe how this actually takes place. All you need to do is be able to illustrate, okay, this 6th carbon is now up top. That's all you need to know. Okay? You don't have to describe why. You don't have to do anything like that. Okay? We just want you to know that this is up top now. Okay? And then we've got a hydrogen down here, because there's a whole lengthy process that we describe on why and how they end up the way they do. We just want you to be able to draw this. You don't have to describe it or anything to that nature. I probably said that 2 or 3 times now. Okay. Then once you get to this step, now you're pretty much on the home stretch. Now you can just copy everything going around the circle here. This stays the same. This stays the same. And then this stays the same. And once you've got that, you're done. I really didn't know whether to say let's grab a book, but if you're one that likes to see these diagrams in the book, that would be on page 752. So, who do you want to be your class representative? Okay? Well, don't think this is a, oh my gosh, oh my gosh. What does it look like there on the bottom? Yeah. Does that look like something you have on your paper? Yeah. Looks exactly like what you have on your paper. No. Unless you draw it incorrectly. You didn't? Okay. So who do you want to pick on, left or right? Or behind you? Behind. And who would that be? Right. Oh, okay. So we got to Got to be included to everybody. What does it look like at the bottom of this paper?
Glucose.
What about your paper?
Looks the same.
Exact same thing. Okay? So one of the things I like to say is we don't know what we're doing up here on this side of the desk. We just make it up. Because you might not know any different, right? What are we doing? Oh. Okay. Well, that's rather unfortunate. Because now you've got a wet notebook, right?
No, I got it off.
Oh, okay. Okay. Oops. This is another one. Yep. Okay. I'm going to do a very similar process to do this. Just like what we did here. These all have these carbon atoms in here. Everything's the same. So this is step one. Okay. So how do we get from step one to step two? What's the next thing we do? We set it on its side. Like I said, just like if you're chopping down a tree. Okay. So we're going to set this on its side. Okay. So where is carbon 1? Okay. Right side. So this is the right side, this is the right side, but is it on the top or the bottom? Okay. Here's carbon number 1. And if you decide or choose to write it like this, that means the exact same thing. Okay? Because on our prior example, we actually drew the carbon atom on there. But you don't have to do that because everywhere there's an intersection, there's a what atom? There's already a carbon atom present. Okay. So now we're going to move over to carbon 2, 3, 4, and then 5. So what does this tell you about carbon number 2? What happens with this OH? Is it up or is it down? Is it up or is it down? Is it up or is it down? We sure? Yes. Okay. What does that tell you about this OH on this carbon? We sure? Well, sure. If this one was down, well, then so is this one. Okay. Then what? What do we do with carbon number 4 here? Is that up or is it down? Okay, it's actually up top here. Okay. How do we get to carbon number 5 now? Is it up or is it down? Okay, since it's on the left side, it's up. Then what's way out here on carbon number 6? Okay, what we have left over here. Okay, so now we finished step 1. This was step 2. How do we close this ring now in step 3? Well, for one thing, we can just go ahead and draw this figure here. Okay. Okay. We all right back there? Okay. We'll just go ahead and put him down there. What happens here on carbon 2? Same thing that we see here. Okay. Same thing here. Okay. But what is significant here on carbon number 5? Mm-hmm. Okay. What is the molecular formula for this structure? How many carbons does it have? Okay. How many hydrogens does it have? Okay. And how many oxygens does it have? Okay. So it has the exact same formula as glucose, but what do you notice that you see on your paper? Are they written the same as the same structure? No. So you could presume that these are, isomers of one another, or just say that they're totally different structures. Okay. I'm not quite sure which monosaccharide that would be. So go ahead and take a peek at this quick. Let's see here. Looks to me like it is you don't have to know that it's gulose. It's just we're just telling you what it actually is. Okay. So the main concept behind this is knowing that if the OH is on the right side, that it's down in the structure. If it's on the left side, it's up in the structure. Actually, I'm pointing to the wrong one. Okay? And that between this step, the second one, and the third one, these two just flip-flop positions. That's all you need to know. So you're just interpreting this structure and then interpreting this structure into this structure and then closing it. Okay? Row. Are we second row? Third row? Okay, so that's all we have. We'll pick up with this again tomorrow.